way of making the electric circuit protected. To replace this, miniature circuit breaker has come into the practice. So the meaning of miniature circuit breaker is identically from electrical power system. Circuit breaker is a bigger component. Circuit make, circuit break is the topic of that. It closes the contacts, it opens the contact with a high current handling ability. That was the real-time application in the power system. Such a component is miniaturized into small, like a 3-inch by 3-inch dimension, miniaturized into local domestic assembly. So hence the name miniature circuit breaker that works on the principle of current flowing through a bimetal thermal strip. When the thermal strip heats up due to Joule effect, automatically that metal will get deformed. There will be a twist of the thermal strip. That twisting mechanism due to heating up of that bimetal strip will make the mechanical assembly to operate and isolate the circuit from the power supply. That is the principle of working of circuit breaker. That was what shown you in the diagram. So this is on a commercially available product shape. This is called two pole. We have two screws here. You can connect two wires and you can take two wires out of this. It means it is two pole MCB. If I have only one connection possibility, one connection drawn, one pole, single pole, two pole, three pole, like that. Multiple control points are available. That name is given like that. How is that internally? Internally, it is having a structure like this, which I'll show you simple outline. You may need to sketch. What is a sketch the MCB, miniature circuit breaker, and explain, or compare the fuse with MCB would be a question. For that, one side wave is shown to you. So there is a incoming current wire. Then there is a flexible wire, current flow through a coil, inductive coil. We call it as a solenoid. Then it comes to a bimetallic strip. Then it comes to the end lead. It means the dark line which is shown, incoming current path. Then through this device, it goes through the solenoid coil. It comes out to the bimetallic strip. It is called a bimetallic strip. Then to the lead outlet taken out. And this is having a rack and pinion like mechanism, which is having a knob to force it on. Suppose this lever, on lever, if it is bimetal strip operate, bimetallic strip bends, deforms by chance, this is going to open the contact. There is a contact established here. This screw which is going out, terminal giving out an external connection, is having a J-shaped arm. You can see it. This is a J-shape like this moving arm. This arm is establishing a contact with the metal wire, which is keeping a contact here. If this J-like structure lifts up means electrical contact is opened up here. That's called circuit is broken. In that way, this lifting mechanism, if it is a bimetallic strip, due to the flow of current through this, when it heats up, automatically it will deform in its shape. It is such a way arranged due to the overcurrent flowing on that metal strip will lift its contact, and automatically lifting of this contact means this mechanism is such a way arranged, this lever trips off, falls down. Falls down means electrical circuit is broken. In that way, this miniature circuit breaker works. So therefore, it is having incoming lead, outgoing lead, solenoid coil, which allows the current to flow through that, a lever to turn on, turn off, and reset. Something is called reset. When it is tripped down, I have to force back. It's called reset. Then there is an arc chamber. This is called a small window which will have quenching of arc, because when the current is flowing through this device, due to that overcurrent, let's say this has a tripped, operated, there could be a spark here. So that spark or arc definitely makes some smoke like fumes to come. Those fumes are quenched here. That is going to just arrest them. It will correct the fumes and get into out. So this way, a small arc chamber like assembly is made here. I'll show that physical structure of that also. I have another diagram which will show you the physical structure of that. You can just see this internally how it look like. I have just shown you a open one. MCBs, the lever which is having a spring mechanism, solenoid coil, and contact out, contact in. Some of the manufacturer have incoming contact on the top, outgoing on the lower. Somebody will have an incoming contact at the lower, outgoing on the top. It doesn't make any difference. So therefore, this is the arc chamber. So you have bimetal strip. Can you see here? Bimetal strip here. So bimetal strip. Then you have the outgoing lead, incoming lead, solenoid coil, the lever, which now let me try if animation runs here. No, I do not have that. So I had animation to click this. Another class, I'll just try to show the animation of this also. So how this works on the YouTube, there are so many videos available. I have just taken one sample video which runs it. In the next class, I will just try to present you, or in my class, I will upload them. Okay. This way, internal structure, you need to just draw one outline of that. So like this, I have one outline which you need to show. So for me, the better is this outline. This outline you can show. This outline is very simpler one. So how you to draw? Draw the outer periphery of, show the incoming screwing lead here, outgoing screwing lead here, one arc chamber, one electrical coil which we call as a solenoid. Then make the metal strip just shown by some structure here. Then a knob you can just sketch it. So you can explain. This circuit breaker works on the principle of current. Whenever the current flowing through this particular device, which is specially a bimetal strip, it's arranged here, exceeds the current rating of that, automatic heating of that will take place, and a small deformation of the metal contact make the circuit isolated. Because of that, the break of circuit, the mechanical movements, because it is a deforming means what? Micrometric displacement occur. This metal automatically make its movement. That movement is encased by the mechanics available here. This is called mechanics, where a small micrometric displacement of this lever makes this on switch. The knob which is held on falls back. So this is mechanics. Therefore, that will isolate the circuit. Suddenly, there is a setup of arc fumes that is taken care of the arc chamber. So circuit has broken. The question comes: when do the circuit breaker operates? Circuit breaker operates in two modes. One is whenever current flowing through the circuit breaker from the lead 1 to lead 2 exceeds the rating. Imagine circuit breaker is rated for 2 ampere. So 2 ampere current is allowed continuously to flow out of this. Why you have provided 2 ampere for a certain application? Suppose your gadget is absorbing 1.5 ampere. Suppose it draws more than 1.5 ampere, definitely it must be a defectiveness in the gadget. It may be an water pumping motor pump which takes the water from your underground pump to the overhead tank. Let's imagine. Suppose that motor got with the water entry and there is a short circuit in the winding. When you switch the motor, automatically motor starts and stops. Then what happens? Electrical motor is drawing higher current than it was drawing earlier, due to electrical leads got connected by conductivity. So because of that short circuit, high current is spontaneously absorbed by the device. Then if you do not have any protection in between, device would have damaged by higher current drawal. So to protect them, by chance, if you have used the fuse would have blown and isolated, which you need to replace often, which is a cumbersome job. To do that replacement, if I have a MCB, miniature circuit breaker, connected in series with the power supply and the motor terminals. Suppose the motor is having a fault. When you turn this switch on, automatically this knob falls down, trips down. Then you will understand. This MCB has sensed the overcurrent absorption by the load. So load may be motor, for example. Why it is absorbing? Definitely you will have a cautiousness. there is a fault in the motor. Cables might have punctured, connected to one another, or there must be some short circuit in the mechanical assembly or electrical circuit, or mechanical blockage in the rotor or a pump might be the reason. So you will be having protection of the motor. So when motor is drawing a more and more current, it must be either overloaded or short circuit. This MCB trips means what? It is protecting the motor being damaged. If I would not have installed this MCB like this way, imagine it would have taken a higher current, tried to start itself, more and more trials, and it would have burned itself, damaged permanently. That prevention happens whenever we have miniature circuit breaker to protect them. So that is an advantage of miniature circuit breaker. When you compare, fuse is a weakest element in the circuit, which is the cheapest element. MCB is a very modern device to replace the fuse. The size of the fuse and size of the MCB are different in moldings. They need a specific space. And cost-wise, cheaper, which is a fuse, which is costlier. Sensitivity-wise, MCB is superior. It sends the current and it trips off. Here, the fuse wire, until and unless fuse wire ruptures, burn into ash or break into circuit, it won't operate. Sensitivity, if I consider, fuse is sluggish compared to MCB. Then reusability is considered. Fuse wire cannot be reused off once it breaks down. We have to rewire it separately by new one. But MCB, it is reset. We say it is stripped off. Thermal metal strip has made its deformation. Once it cools down, it come and engage the contact again. So this is called reusability of the MCB. MCB won't be defective immediately for a first operation. It has several times trip operation. If it executes over a year, maybe metal contact get permanently deformed. That time only we need to replace the MCB. I would say repeatability, accuracy, and lifespan is considered. MCB is far better and highly secure. So to tell you one simple example, everybody is having a household mixer grinder in their kitchens. You will be finding whenever a mixer is running, definitely due to the load in the cup, whatever the kind of grinding or mixing you are doing, sometimes the mixer motor stops. We say our kitchenware operator, mother, sister, brother, who is helping them, definitely find a block of that gadget. They will turn in and around. They will see there must be some overload trip point. They will press it, they will reset it, then automatically mixer grinder starts. Then what is that? It is the same circuit breaker miniature I am speaking. The shape and size is different, but the concept is a bimetal strip on whose deformation broken the electric circuit contacts that made the safety of the device. If that mixer grinder thermal strip was not provided, let us hope, can you see your mixie will remain for your next usage? Definitely it may not be there. Therefore, to protect electrical devices on overdrawal of current, some safety precautions need to be utilized. Instead of MCB over there, fuse was protected. In the kitchen, rather than making a kitchen application, we have to do electrical repair. Replace the fuse like that. It is not task of the kitchenware or kitchen people. So in the hotel or in the houseware, like that, it become a cumbersome job for them. Therefore, this kind of miniature circuit breaker definitely help. This is common in modern house electrical wiring. In every modern house, you will find for the replacement of the fuse, MCBs are put. Everybody is knowledgeable. Whenever this strips off, these are very sensitive, accurate, repetitive, and they last long. These are the features making it popular, but cost-wise, little costlier. That give a good service. That's what safety we have to account here. In this way, we have single pole, two pole, multi-pole at higher ratings available, from minor rating to very large rating available. You can imagine an industry, a person intact with the power supply, if this kind of circuit breakers are there to trip on an occurrence of certain high draw of current, definitely they save the life. Otherwise, the person who got in contact with the live would have lost his life itself. So in such area, some part of the safety aspect is are going to help. Okay, this was about the MCB and other. Let us move ahead with the one more concept. What is electric shock? So, whenever we use electrical gadgets in our day-to-day life, because we are dependent more on automation, definitely much of our electrical, equipments powered by electricity. I can say electrical equipments only. Oftenly, due to the aging effect, due to the internal failure of the insulation, they charge themselves. It means to say metal bodies of those electrical gadgets come in contact with the live wire of the gadget. That time, any person who is using that gadget, operating that gadget, performing some activity may experience electrical shock. That is called electrical shock is nothing but injection of additional current into the human body. Now I'll come to a conclusion. When do you sense this? How do we sense this? For this, we have at least a current rating here. Suppose the current flowing in electric gadget. Imagine an electric iron box, which is commonly used in household for typical iron purpose. Suppose that is having a metal enclosure. Imagine that is having a metal enclosure. Nowadays we have sophisticated electrical iron box where metal enclosures are not there. PVC moldings are there. Probably touching of metal parts is almost taken out. That's the latest design we get into the market. But hope a conventional iron box where there is a metal enclosure, a stainless steel or any aluminum like frame is available. We hold it with the insulation handle. We iron by electricity supply. The metal enclosure will not be having any electrical contact, undue inductions in that whenever it is a brand new tested. Over years of time, definitely there will be internal defectiveness due to the contact, due to the any failure, that metal contact get charged, get contact such that those electrical charge constitute a current. So suppose a current is induced in that, charges are induced in that. Usually, whenever we touch that by human hand or any part of the body touches that metal enclosure, which is live, plugged in. Suppose the current flowing through that body is about 1 milli like that. You will not feel any sensation. Suppose the current is 1 to 3 milliampere. A mild sensation we may feel. If the current magnitude increases 3 to 10 milliampere, it is painful. Then it is 10 to 30 milliampere, muscular contraction, and you may lose the control. And 30 milliampere to 75 milliampere, we may feel respiratory paralysis. And the current magnitude increase 75 milliampere to 4 ampere, ventricular fibrillation. We feel a struck of the pumping of blood to the vessels or like that, ventricular fibrillation. And the current above 4 ampere, a tissue begins to burn, heart muscles clamp and heart stops beating. This is the effect of electricity and injection of additional charges into the human body. Now we should know why it do happen. The first question comes to everybody's mind. Because human body the parts of the body respond to the brain with respect to electrical signal. So that is a stimulus set by the brain to the respective organs to make the action as directed by the brain with a neuro signal. There will be a signal flowing to the nervous system, and accordingly our parts of the body respond to the brain to reach its end desired activity. When it is being performed by that normal operation, whenever human body get injected with additional current, definitely there is additional current flowing in the human skin or a part of the body where open, definitely the signal which is sent by the brain get affected. There could be a mismatch, a failure, and we get affected by this additional injection. In this manner, we may feel a mild sensation, itching or tingling effect painful scratch, muscular contraction, and respiratory blockage, or feeling of tiredness, or respiratory, you can say it is painful to take respiration like that. Or if the current is so high, if I touch the wire live by hand or by walking on that wire, if I touch live wire contact my foot or something like that, so I may feel so shocked. It will have clotting of blood itself. The vessels definitely get blocked, and the pumping activity of the heart become very painful, and heart experience higher stress to pump. So blood start clotting. So in that way, ventricular fibrillation takes place. Or if it is so heavier, it's definitely going to have heart attacks. So this is how electrical shocks are very dangerous. In this regard, amount of current conducted through the body is important. Path of current through the body is also important. The length of time a person is subjected in contact with the current is also matter. These are the parameter which really make seriousness of that electrical contact. You might have seen some clip of videos, people touching the electrical distribution line, on the transmission line, touching, live, playing. Some people, superheroes, won't get shocked, but not all the people do that. That's how. So when we are live with the live wire, when we get connected to the earth, definitely our body resistance come into picture. So we have another one view here. I'll just show you how is that. I'll just show you how that electrical contact establishes and make electrical shock here. You can just see a similar one I've shown here. Okay. So there is another phenomena here. So human body, approximately it is 500 ohms to 600 k ohms. Person to person, the body resistance for electricity. I am talking about conduction of current through the body as a such skin or a moist or a sweat, salty surfaces definitely possess a resistance between 2 points on the body from ohms of 500 to so much. So some people feel electric shock very early. Some people feel late because of their individual personality and the property resistance concern to electricity. Therefore, it's very dangerous. One should not play with the electricity. That's the first cautiousness. This highlights when do electrical shock occur? Whenever human body come in contact with a live wire. And we know that current always prefer lowest or low resistive path to complete its circuit. Circuit is supposed to complete via wires. When we touch as an element, we become part of the circuit to conduct back to the circuit easily. So therefore, we should not be in part of that, or we should not become victim of that. So electrical shocks are natural whenever we use electrical gadget. Only thing is the quality of the instrument, quality of the gadget, and the safety precautions. Practice of operation can only protect us, and being immune to such makes the things. So this is how electrical shock is highly guaranteed. Even a mobile adapter, mobile phone, or the plugging, or any transistor, anything electrical and electronic gadget, when you feel. So milliampere to an ampere is a sensible current. We should not play with that, because our brain is functioning with all its organ with the electrical signal itself. That is getting affected. Hence, we have to experience electrical shock depending upon the resistance of the individual human being. Then we have something called as a table of information, which I said. Then I have something called as how to provide safety for that. Yes, safety for that is concept of earthing. So what is electrical earthing then? I was speaking about electrical gadget like an iron box, maybe a pumping motor. If there is a chance that gadget got damaged, knowingly and unknowingly I plugged it into the supply, and knowingly and unknowingly I encounter or contact with the live part of that, I establish a shock or get connected to the fault point. Then how to get protected from this? For this is to safeguard the life in the residential or commercial or industrial applications. Whenever the person is using electrical equipments or gadget, who has a chance to get contact established with the metal enclosures of the gadgets, the safety is earthing. We have to provide metal enclosures of electrical gadget connected to the earth point. There could be a earth pit in the system. Now I call you back. In an house, whenever we are trying to have electrification permission, electrical contact from the corporate office or distribution company, they go for earth pit. Means we have to dig down the earth pit, process it with a layer of salt. We'll see the diagram. Earth pit maintenance and earth point need to be established. That is called earth crust is assumed to be at zero potential. It means we have to provide one conductive path from the earth pit to the electrical junction box. Now I will turn you back. Whenever you find electrical junction box, you will be having 3-pin socket. You will see bigger diameter 1 pin and 2 smaller holes in the triangular fashion. The top one, which is bigger, is called earth pin. The other two are line and neutral. Definitely every electrical equipment will have 3-pin socket. When you plug into that socket, automatically the earth pin of that connected to the larger diameter get connected via the wiring of your building to the earth point. Whenever that electrical gadget, maybe iron box or a computer or a laptop, whatever is so, having a 3-pin contact, definitely the excess induced charge in the metal enclosure are driven to the earth pit, so that even though you touch the metal enclosure, you will not feel shock. That is the provision called earthing. So earthing is providing an electrical contact from the metal enclosure of the electric gadget to the earth point, driving it to the earth point. The concept here is current prefer always the low resistive path. If a human touches that, human possesses 500 to so much of kilo ohms of resistance, but the conducting wire possesses in terms of ohms of resistance, current to rush to that first to the ground. Therefore, earthing is just providing an electrical contact with the metal enclosure from the earth pit, which definitely ensure safety. Then I have objective of earthing. What is that objective? It saves human life from danger of electrical shock or death by blowing a fuse, or to provide an alternative path for the fault current to flow such that it will not endanger the user. The first prevention is, think of an iron box itself or electric kettle, electric geyser. Rather than taking the water from that, when I touch the tap, if it is so metallic, definitely I'll be in danger. So that metal enclosure is earthed first. That will drive the excess current to the ground first. Whenever I touch, I become parallel to the circuit, so that it will be a minor current flowing in my body like that. So it is going to protect and safeguard the life. To protect buildings, machinery and appliances under fault condition, that is to ensure that all exposed conductive parts do not reach a dangerous potential. This is what I was speaking. Metal enclosures of the electrical gadgets were connected to the earth point. It means to say, if there is any chance to get induced in them, or any high voltage induction in them, will be driven to the earth potential. So therefore, at that safeguards the operator who come in contact with that. It provides safe path to dissipate lightning and short circuit current. It absorbs the higher fault current, any lightning strikes which are occur, that is taken down to the earth point. And it provides stable platform for operation and sensitive electronics. It means electronic devices, laptop, mobile phone, tabs, or any sensitive electronic circuits are very critical. Whenever the fluctuation, any high rush of things happen, they start malfunctioning and may get damaged. For them, earthing is very, very necessary. So therefore, these are the points we need to take care. Then how earthing is being done then? Just see this example. There is a transformer, just you can see, there is a toaster having one fuse, a very large 100 ampere fuse is provided, another 15 ampere fuse is provided, and it is allowing toaster to work. You can see here. So brown and blue are the two wires, and there is a greenish earth wire. Can you see this? Yes. A human is just touching this. You can just see. The toaster is faulty. Toaster is faulty, and metallic enclosure is being touched by the operator who is trying to toast the requirement. Then the resistance which the earth wire is having is about 22 ohms here. Greenish wire is shown here. You can just see this 22 ohms. Then human body is intact with the enclosure of the toaster. You can see the leakage current is flowing through the earth wire as well as along with the body of the human operating. Now this earth wire is perfectly connected. We will not see any current rushing down to the human body. It would have taken perfectly over here. If this wire is not there, just imagine, earth wire is not at all there. Now I am talking about the connector of a mixer grinder, connector of a television or any gadget. Oftenly, if there is no 3-pin socket in the house, what we'll do? We modify the connection to 2-pin. One of the bigger pin we break down and we make only 2-pin. That's what we are calling the danger. When the third pin, which is to be a safety pin, that is called as earth, you are eliminating and you are touching the gadget. The wire which would have carried the faulty current is no more there. Then your body become a third wire for that. So the fault current rushed down to the body. That is a need that earthing must be there. So earthing provide safety for the operator. The leakage current, undo additional current in the body of the metal enclosures will be driven to the earth. So suppose this toaster is faulty, this wire is not appropriately earthed. It is how a person feel electric shock. If it was there perfectly, he would have enjoyed working even with the faulty toaster. So in this way, we have two methods of working. Let's see case study. Suppose I have a single phase supply to imagine this is the iron box. Iron box is a resistive load. We have a line, yes, iron box, back to this. A human is operating it. Equipment is perfectly brand new, no fault at all, even no ground in the home. Grounding is open, you can see here. Grounding is not there for this pin, only 2 pin is there, 2 pin, 1, 2. So equipment is very healthy. Apparatus is not earthed, not provided. So operator won't experience any fault because it's a brand new, trusted. Over in years of usage, what may happen? This device develop internal loss of insulation, leakage, etc. You can see here. Apparatus is not earthed. Even there is no earthing, 2 pin. I use it past 2 years, 3 years, but device has become developed aging effect. Insulation property of that is lost. When I touch it, I may feel electric shock. This is how person who is touching, who touched earlier, did not felt it, but now he is feeling electric shock. This is because of insulation of the device has come down, degraded, aging effect has come, internal faults might have been developed. That made the live part of that or metal enclosure, when he touched, he became path for the current to flow, and person experience electric shock. Depending upon the amount of current flowing through his body, the states can be designed. Maybe minor fault, major, just a minor sensation, very shock, ventricular fibrillation, even a death may occur. This is how electrical shocks are very dangerous. Suppose to provide safety for this, what is being done? Just watch this diagram. This device is having 3 wires. One is line, neutral, and a metal body. You can see greenish rectangle now, connected to earth pit. Third pin is plugged into the socket. Then, even though equipment is faulty, you can see here, even though equipment is faulty, earth pin is provided with a wire. When the human touches it, the path for the current is 2. One is a low resistive path for the earth pit and a resistive path by the human body. Human body experience a comfort now because there is a minor milliampere flowing, if at all. Otherwise, every ampere will rush to low resistive wire to the earth. Almost resistance of this is negligible, 1 ohm or 2 ohm. Human body experience or show ohms to hundreds of ohms to kilo ohms. Definitely current prefer this low resistive part. This way earthing safeguards the electrical operator or operator who is using the electrical gadget. By chance they come in contact with the live part of that, conducting part of that, human life is protected. Hence electrical earthing is very, very necessary. In line with this, how earthing is done? Earthing is done in two ways. One is pipe earthing, another is plate earthing. Depending upon the type of the premises, current in the system. Domestic house means normal living house where current is not more than 10 ampere. We prefer pipe earthing. This is the first mode. In case of industry, there are hundreds of machine or number of machine higher the capacity of 10 kilowatt, 100 kilowatt, megawatt, like that. There could be a fault current in terms of hundreds to thousands of ampere. That time, such a fault current has to immediately be rushed to the ground, absorbed by the ground, dissipated into the ground. Then it should have provision. That provision done by metallic plate mechanism. So this is how plate earthing is done in industry. Pipe earthing is done in the household. Let's see what is this. I have another one. So this is in every normal household domestic premises. Electrical earth pit is done. What is this exactly to visualize? Just imagine a plot, a flat plot to be constructed. You have just outlined. Building boundaries have been framed and electrical earth point is digged into. You have to dig down a deep hole up to what meters? 2.75 meter. You can see the left side here. Left side 2.75 meter and a depth of 2 meter. About 4 meter plus you need to dig down a hole into the ground, earth crust. Then you have to bury inside a 38 mm diameter galvanized iron tube. This is actually a pipe. Galvanized iron pipe lay down. Before laying it down, the edge of that conically cut, corner cut, number of holes are marked on that body. Means through holes are provided. Then it is buried inside the hole or into the deep slot cut by the construction fellow, and alternate layer. You can see here 15 centimeter a layer of charcoal salt. Charcoal salt is assembled in the form of layer 1, layer 2, layer 1, layer 2 around that GI tube. Like what you can see here, 15 centimeter this side, 15 centimeter this. You can imagine a rectangular cut or a square like cut. Centrally you inserted this pipe. Imagine. Then around that pipe you should pour charcoal salt as a layer 1, layer 2, layer 1, layer 2 to improve the conductivity of the soil. Then this galvanized iron pipe is coupled, joined with another tube, galvanized tube, and brought up from 2 meter deep down to the earth. Next to 2.75 meter or 2 meter approximately, it is brought out. This is called as cast iron or a cement structure. Like you have municipal corporation water taps where we have underground mechanism. We will be having a lid for that and we will have provision. Similarly, earth chamber we call this as. This is called earth chamber. It may be a concrete, it may be a cast iron available mechanism fit, and it's made at the ground level. Exactly your floor of your plot at that ground level, it is flat. This is the surface of the earth. I am speaking below the earth surface. This entire mechanism should be digged down and bring up the pipe from this 38 mm diameter pipe joined with a 19 mm GI pipe, bring it out and make a funnel. So it means from this funnel I can pour buckets of water which will come down through this pipe and dissipate into the earth. So depending upon the season, depending upon the soil, rocky soil and loose, meshy, like that, soils from place to place keep different. So therefore the earth electrical conductivity also keep changing. So we want this earth pit to be always at a very, very low resistive point. so that it should absorb any undue inductions connected to the metal enclosure immediately to the ground. I want to maintain the potential to the zero possible. Hence, buckets of water seasonally should be poured into this. In case of rainy season, winter, we may not. In the summer and all, when the lands are very dry, we need to pour buckets of water to this ground chamber or earth chamber, so that that water pour down will come down and make this contact established with the earth very easily. Therefore, once the 19 mm pipe is brought out, this chamber has an open lid. You can open this like you are opening up a box. How you open the box? Open the lid and you will see this chamber, and close back. It become a flat surface. And after the building is ready, you may make some modification for this and keep it working for you. But for us, what is important? This contact of this tube, GI tube, electrical contact is important. Through this galvanized tube brought here, one cable will run, a GI wire. You will see a messenger wire for the cable TV and all, how they tie. Likewise, we require a good GI one, good and conducting galvanized iron wire from this neck here, tied and bolted, and it is brought into your premises and terminated at the meter box. Now I'm coming to the meter box back. Meter box is nothing but having a connection from domestic premises as well as from the supplier board electrical pole, where supply come and land at the meter box. Now we have one line, one in neutral and one ground available. So all these three pins throughout the premises travel. This way electrical distribution occurs. This is called electrical earthing by pipe mechanism. So wherein what you are supposed to remember, one rough sketch of this kind, and a pipe of 38 diameter, pipe of 19 mm diameter, depth of 2 meter, depth of 2.75, a chamber, and a drawl of this cable to the meter box. Alternate layer of charcoal salt for a depth of 15 centimeters should be there. That's come under domestic earthing for premises. Suppose the same mechanism if I think of the industry. So in case of industry, we will have very high fault current. The same mechanism is done in this way, plate mechanism. Can you see this plate mechanism? And just go down this way. This is having a GI pipe from the earth surface here, dig down and assemble the chamber mounting, and GI tube for 3 meter deep down. You can see this 3 meter down the earth, dig down, and there is a 90 centimeter by 90 centimeter surface, a cuboid like you can imagine, just an opening. There you have to bury copper or aluminum plate of 60 into 60 into 32 centimeter. That is a copper plate, or it can be aluminum also with the dimension increased. That copper plate is vertically inserted into the earth. Insert it and couple a GI pipe, this GI tube which is getting connected here, bolt it, and electrical contact of this copper plate is with the GI tube. GI tube is having electrical contact with the household meter wire. This way a pipe to plate conversion comes. Here it is a plate and the GI tube get connected to the plate earthing. So therefore throughout this periphery of this, around this 15 centimeter, you bury the charcoal, salt and complete it. Then completely furnish this, bring the connection back and pour the buckets of water so that this soil inside this area become conducting. So this way, this is having an ability to dissipate higher fault current in terms of hundreds to 1000 ampere. Because the material what you have used is a copper plate or aluminum plate, very good conductor. That good conductor is buried into the earth crust at deep down by 3 meters below the earth surface minimum. Then the contact of that is brought to the meter box wiring side, where one neutral, one line and one ground will run all around the premises. Whenever any electrical device develop a fault, earth pin drive that current into the earth pit. This is how safety precaution is encased in the earthing. So this way there are two diagrams, method 1, method 2. For this also one rough sketch, its protection mechanism need to be understood. So this is